Alright, this last video for this unit, it is on direct and indirect variation. Sometimes indirect is also called inverse variation. And in this type of situation, K is going to be a constant or just a number. And that constant, of course, won't change. So direct variation. As Y varies, it directly varies as X does. In other words, they're saying is X increases, Y increases, or as X decreases, Y decreases. All right, one's going up, the other's going up. One's going down, the other one's going down. And here's an example of that. Here the X values are going up, the Y values are going up, and we can write an equation. This is the direct variation equation. Notice it kind of looks like a slope-intercept form of an equation. And if I were to divide both sides by x, I could find the value of k. And so here, 3 divided by 1, 6 divided by 2, and 9 divided by 3 gives you a constant of 3. So the direct variation constant is 3 for that problem. Indirect variation, y varies indirectly as x changes. As y changes, x changes indirectly, or the opposite. In other words, as x increases, y decreases, or as x decreases, y increases. Here we go, I got the x's increasing and the y's are decreasing. And the equation is y equals k divided by x, so it turns into a rational sort of equation. And the constant would equal k equals x times y. If I multiply both sides of this equation by x, so k equals x times y. And you can see 16 times 1 is 16, 18 times 2 is 16, and that's supposed to be 4 right here. So 4 equals 4 times 4 equals 16. And here I have a couple of problems on the right here. There we go, that's fixed. Here we go, have a couple problems on the right here. Given the equation 2xy equals 10. All right. If I divided both sides by 2, I'd have xy equals 5. I'm trying to find the constant, and therefore the constant equals 5. And I could put it into this format here, which makes it look a little more like an indirect by dividing both sides by x, and I'd have y equals 5 over x. The constant is in the numerator and the x is in the denominator. Here, this is an example of direct variation. In this case, x equals 2 times y. Divide both sides by 2, and x would equal 1/2 y. Sorry, y would equal 1/2 x. 1/2 x would equal y, and so the slope, if you will, would be 1/2, and the constant would be 1/2 or 0.5. And this is the type of problem you'll be doing. Here we have if y varies indirectly. So I know I'm starting with the indirect variation equation. If y varies indirectly as x, if I have the problem if y equals 3 and x equals 12, and so we're stopping right there, I plug in the 3 and the 12, multiply both sides by 12, and I get k equals 36. So my constant for this indirect variation is 36. And so then I set up the problem to find x when y equals 4. So I've plugged the constant in, y equals k over x, so y equals 36 over x. Then I plug in the 4, which I know the y value is, and I solve this for x. Multiply x to both sides, and then divide both sides by 4, and I find that x equals 9. Here's a direct variation example. If y varies directly as x, there's supposed to be a y in there. If y varies directly as x, if x equals -5 and y equals 15. So I start with the direct variation equation. Plug the 15 and the -5 in, divide both sides by -5, and k equals -3. And therefore I can find y when x equals 7. Start with my direct variation equation with the constant plugged in. Then I plug in x for 7, or 7 for x, and I can then calculate that y equals -21. And last example, if y varies directly as x, indirectly as x, if y varies indirectly as x. So I start out with the indirect equation, plug in the 24 and the -4. I have to do these. I have to do this first step in order to find the value of the constant. All right. So in this case, I multiply both sides by -4 and get k equals -96. And then to find y when x equals -12, I'll plug in the -96 in for k, and then I'll plug in the -12 for the x. And here I can just divide -96 by -12 and find that y equals 8. If you've got any questions or if there's anything I can help you with, please, please, please put it in a post. And folks, if you've watched the video, please let me know you've watched it. And if there's anything that you need a little extra help on, or that you think you have a question about, please, please, please post. And if you don't want to post, or if you prefer not to post on the board where everybody can see it, please feel free to text to Edmodo me a question, or do me a direct post on Edmodo, or email me, or text me, or call me. I'd be glad to help you out in any sort of way.